Hi, this is John Mackie with Neural Netting. Welcome to the first episode in the Machine Learning Primer, where today we'll be examining how does machine learning fit into artificial intelligence. Thanks for joining me. Let's dive in. Okay, so AI, artificial intelligence, what exactly is it? Well, one way to talk about it is to think of driverless cars, computers behaving intelligently and autonomously, right? What better visual than a driverless car? Now, what is this versus? Well, it's versus computers doing what they are told. So, for decades, software engineers have been constructing expert systems, tightly constrained, rules based software solutions that perform a single task very well. There's nothing wrong with that. In many cases, it's the right answer. Think about updating the firmware on your TV. You can look for it on demand via the setup menus or let the TV look for it once in a while, but it's a problem best solved with traditional technologies. It doesn't require intelligence. Now think about driving a car around in a big city. That requires intelligence. We're getting nowhere fast with driverless cars until the rise of AI. There's usually a wow factor involved when encountering a specific AI implementation for the first time. We've come to expect traditional software solutions to perform their duty well. Think of Microsoft Word, Gmail. New AI applications often continue to surprise us. Think of the very first time you talk to your phone or let your car park itself. So, what are the different types of AI? Well, the first type is narrow AI. Think highly focused. Apple's Siri on the iPhone is a very helpful with phone related tasks, but try asking it something outside the box. Why is my partner mad at me today? It's not going to be very helpful. Spam versus ham filters for email. When's the last time you had to set up a junk mail rule? You don't. AI has effectively solved that problem for you. Face recognition on Facebook, very focused, wickedly accurate, but the underlying ML implementation would be useless if you tried using it to fly a drone. This is what the narrowness is about: extremely performant AI solutions in a limited setting. The next type of AI is general AI. Think of the kind of intelligence that would rival human capacities. It doesn't exist yet. The human capacity to adapt to the challenge at hand underscores the agility and flexibility in our intelligence. If you and I needed to learn to drive a forklift, we could. If we needed to master flying a drone, we could. This kind of generalized intelligence that can be directed at a wide variety of tasks has not been achieved in AI. And the final type is super AI. Now we're talking about the kind of intelligence that we can only speculate on since it exceeds our own. General AI must first be achieved prior to super AI, and speculation on what this might entail has led to many thrilling sci fi books and movies. Bottom line, we have no idea. And we wouldn't create it, general AI computers would. So, if we have three types of AI, where does machine learning fit in? Machine learning is a type of narrow AI. It's purpose built and is focused on a relatively small spectrum of tasks. Remember, narrow AI is the only type of AI in existence right now. All of the technological miracles we're immersed in are brought to us courtesy of machine learning. As we've discussed, traditional software technologies have been unable to crack certain nuts. These tend to be the areas where machine learning shines. ML is not the solution to every problem, but it is often the solution where previous technologies have failed or come up short. Remember the maxim: to someone with a hammer, every problem can look like a nail. Don't go down that road with ML. There are plenty of areas where traditional technologies are the right answer. Well, what is machine learning? Well, essentially, it's big data plus an algorithm equals a model that serves useful. So, a function that learns by sifting through mountains of data and gets smarter at its task, that's a machine learning model. This trained model can then be deployed and serve useful as it's exposed to new data that it's never seen before. Traditional software doesn't work like this. It doesn't evolve as it's exposed to more data. It just blindly follows the rules it was designed with. In machine learning, for example, you can feed a neural network, which is a type of algorithm, a ton of images of dogs and cats, and then take that model and deploy it to the cloud, say Microsoft Azure, Google Cloud Platform, or Amazon Web Services, and then present a new picture to that model and ask it if it sees a dog or a cat. This kind of functionality is essentially unsolvable using previous technologies. So, what is machine learning good at? How do you know when to reach into the ML toolbox? Well, if you have an existing software system that requires constant tuning or involves a laundry list of rules, you may have a good candidate on your hands. When the ongoing costs of maintaining a system are high, this can be a good indication that ML might be a better fit. There are many real world problems for which traditional technologies have come up short. Machine learning is powering the phenomenal advances we're experiencing by filling in these gaps. Problems that are by definition in a high state of flux. Think about new images being posted constantly and needing to be classified. Those are often best serviced by ML solutions. And then patterns in data are obvious when the data is small. Think of a spreadsheet with 100 rows. As the amount of data grows, now picture a spreadsheet with 1 million rows, it quickly becomes impossible to spot patterns or trends. ML technologies excel in this arena. We'll dive deeper into this topic in future episodes, but for now, understand there are three major branches of ML. Going back to our example on dog versus cat images, this would be an ML model that falls under supervised learning. The algorithm was trained with data for which it was given the correct answer, thus the name supervised. Unsupervised learning involves algorithms sifting through data for which there is no answer. A recommendation system, like Netflix uses, is a good example of this kind of ML implementation. The algorithms are looking at viewers' streaming habits and identifying similarities by which they can make future recommendations. So they're clustering subscribers together and making intelligent suggestions based on historical streaming habits. Reinforcement learning is well known in the gaming world. A software agent operating in an environment makes observations, takes actions, and receives feedback, which may be positive or negative. The objective is to learn to maximize positive feedback by trial and error over time. Real world applications abound. Games, of course, robotics, smart home devices like the Nest thermostat, and automated stock market trading programs, just to highlight a few. That's it for this episode. Thanks so much for watching. If you got something out of it, please click on the thumbs up icon below and subscribe to the channel if you'd like to see more. Next time up, we're going to be examining the many different types of machine learning and in what particular scenarios they're useful for. Hope to see you then.